Scaling up industrial Bitcoin mining to multi-megawatt capacities creates immense pressure on the network routing and orchestration layers. Currently, the industry operates through siloed, proprietary software environments. Purchasing a cluster of machines from one manufacturer typically locks an operator into that vendor's specific management interface. This reliance on proprietary tools fragments the data ecosystem, leaving information from the power grid, cooling systems, and high-density ASIC racks in separate, non-communicating silos. While increasing physical hash rate is a straightforward mechanical process, the software required to manage and balance those new machines across incompatible systems becomes exponentially more complex as the facility grows. This chart illustrates the efficiency gap. As hardware scales linearly, management costs rise at a nonlinear rate, creating an operational ceiling for large-scale miners. Tether introduced the Mining Development Kit, or MDK, to bypass this vendor lock-in and standardize the management layer. MDK functions as an open-source, full-stack development framework, allowing operators to build their own tools rather than relying on restricted, manufacturer-provided software. This framework expands upon the architecture of Tether's Mining OS, turning the operating system into a programmable foundation for custom applications. Tether CEO Paulo Arduino describes the kit as a blueprint for a standardized architecture intended to make disparate hardware devices universally compatible. This transition replaces hardware-specific management with a unified software framework that organizes infrastructure based on its actual capabilities. The base of any operation is the bare metal. This includes the ASICs, the high-voltage cabling, and the cooling infrastructure. Legacy APIs must communicate with this hardware using specific manufacturer-defined commands, which prevents different types of machines from working as a single unit. Tether's Mining OS acts as the abstraction layer positioned directly above this hardware. The OS pulls operational data from the persistent storage on each device. It bypasses manufacturer specificities to read raw telemetry like temperature and hash rate in a uniform format. Standardizing the operating system is the mandatory first step for building programmable infrastructure. Above the OS, MDK utilizes a capability-based architecture. Instead of letting each device dictate its own communication rules, the system requires the hardware to expose its functions as standardized capabilities. These capabilities are managed by the central orchestrator, which organizes the entire fleet through a single interface. The orchestrator receives incoming requests and routes them to the correct hardware capability, regardless of which manufacturer built the underlying machine. This decoupling allows engineers to swap physical hardware at the base level without rewriting any of the core backend code. Within this orchestration layer, the framework uses modular software agents called workers. Each worker is an independent module that executes specific logic by plugging into the orchestrator and calling upon hardware capabilities. Because these modules are isolated, an engineer can add a new service or monitoring worker without disturbing the core system or the existing hardware nodes. Using modular agents to interact with standardized hardware functions increases the security and stability of the entire network. At the top of the stack, MDK provides the tools necessary for developers to build user-facing applications. A JavaScript Software Development Kit, or SDK, interfaces with the orchestration layer to pull data streams into the backend. These streams feed into a React-based component library, which provides the visual elements for custom dashboards. The system is cross-platform, meaning these tools function identically across Windows, macOS, and Linux. This open framework contrasts with the closed, rigid interfaces found in legacy hardware systems. By utilizing standard web development tools like JavaScript and React, DevOps teams can build and deploy custom monitoring environments as quickly as their operations require. This software stack remains efficient whether it is managing a single home mining unit or a global enterprise. The orchestration layer allows the framework to manage multi-site operations across vast geographic distances without a loss in control. The React frontend enables operators to unify the data from every dispersed site into a single comprehensive management interface. Interoperability at this level removes the software inefficiencies that previously limited the growth of industrial mining firms. This infrastructure is designed for a specific long-term transition, the shift toward autonomous, intelligent mining operations. With hardware capabilities fully abstracted, operators can deploy AI-driven logic to manage these endless rows of server cabinets. For example, an autonomous fault tolerance module could detect a hardware failure and instantly reroute logic to a redundant board without any manual oversight. Tether's MDK moves Bitcoin mining away from manual infrastructure management and into the realm of highly programmable software engineering.